Hello, this is going to be a brief little lecture about ocean acidification and what upwelling is. So, what do you notice about these molecules or ions? Take a moment, look them over, make a little list. Hopefully the first thing you noticed is they all have carbon, not only in name, but also in each of the chemical formulas. Taking a little closer look, you might notice they all have CO2. They also have another oxygen, but that's something a little different. The idea, though, is that they have CO2, so you can think of where this origin of these carbonate chemicals are from. You also might have noticed that they go from no charge in carbonic acid, see there's nothing there, to a charge of -1, charge of 2-. So they do increase in charge and have different charges. You also might have noticed there's less hydrogen as you go down as well. So that'll be something we'll look at on the next slide. There's a few steps when we think of ocean acidification. So the first step we've seen before, the gas in the atmosphere dissolves into the ocean. Then we have this CO2, which is the aqueous one. Maybe I'll draw a little arrow, not to be confused, is going to react with the ocean water that's already present and make H2CO3. This is our carbonic acid from the other side. So that is going to then react and produce hydrogen ion and bicarbonate ion. And this hydrogen ion is very reactive. This is what causes the acidification, because you remember with H plus, as that goes up, pH goes down. They work opposite of each other, which is acidity goes up. The more hydrogen ions you have in solution, the more acidic it is. Now this bicarbonate ion still has a hydrogen, so it can lose that hydrogen to the water again and make a carbonate ion and hydrogen ion. So these acidic hydrogens can greatly increase the acidity of the ocean. Now, when I say greatly, it doesn't take much to have pretty drastic effects. Even a pH of 1 is meaning that something is 10 times more acidic. And with the sheer volume of the ocean and volume of the atmosphere, that can have a pretty dramatic effect overall. Now, a separate component of this acidification is this kind of churning and mixing of waters. We saw this quite a bit on the carbon cycle, from like deep ocean water to surface water. So what occurs is you have offshore winds. That means they come from the shore and move off the shore. So they're going to the right, pushing the water up this top. And this is warmer surface water because, of course, you got the sun giving off a whole bunch of energy. And so the surface water is going to be warmer. And this is going to move across. As this moves, it's going to churn up and bring up some of the colder, which has some smaller plankton in it, fish. Deeper, colder, nutrient-rich water comes up, in which we have this mixing of the water, this upwelling. So this makes the difference of the surface ocean and the deep ocean. You got in contact with the atmosphere, so this is where you're going to have your CO2 gas go back and forth, CO2 aqueous. You have sunlight, so that sunlight is going to help with the plankton. Now it has low nutrients at first, but that's where the high nutrients eventually get brought up to the surface. And those nutrients with the plankton is what enables things to really grow. Of course, deep ocean, no contact with the atmosphere. It's very CO2 poor. And of course, no sunlight. So sunlight can sometimes be activation energy in certain reactions. And so it's colder. And as you may know from being colder, usually reaction rates decrease. So all of these are kind of playing a role in how the ocean is mixing and thoroughly moving throughout. And this upwelling is a very important concept in ocean acidification and how the ocean works.